Okay, hi everyone. I'm Mike, and today I wanted to show you a little bit about Velociraptor. So we're going to have a little bit of fun playing with it, and just to get an idea of this tool, which is a digital forensic and incident response tool. And I know some of you are doing DFIR, and some of you, maybe aren't doing DFIR or don't know much about the field, but don't worry, because you won't need to know a lot about digital forensics. We're not really going to go into like the bits and bytes, but we're going to try and talk about why you want to do that digital forensics, and so you'll be able to click through the interface and find your way around, and then just get an appreciation to what this field is all about, what the tool's all about. So we're not going to do anything too technical, but if you are doing the FIR and you have been doing it for a while, and you're used to the way that digital forensics is done, traditionally, which is much more complicated and it takes a long time, then you would appreciate the ease of use that Velociraptor gives you in actually doing this work. So so hopefully you'll get something out of it. All right, so I've got the presentation here. You can have a look at it. So the slides are up at present.velocidex.com. So Velocidex is the company that started Velociraptor, the founding company. And as you know, it's now acquired by Rapid7. So now we're a Rapid7 company. So Rapid7 company. So this is like a hands-on tutorial. You can use your own machine or a VM or whatever you want. It's non-destructive. We're not really going to set up a scenario. We're not going to run malware. We're not going to do any of that stuff. We're just going to run Velociraptor, and you'll use that to look through your machine. So I really don't know what is going to be on your machine, right? Like it's your machine. So you might find interesting stuff or not, but it's part of the experience. And normally when I do this, I use a clean VM, but I was looking through the workshop yesterday, and I was like, clean VM is very boring because there's nothing happening on it. So for this one, I decided to use my development VM, which is been used for a couple of months. There's a number of things installed, uninstalled, browsing activity, whatever. And so we're going to see what's there, as part of our, exploration. We'll just play around with it and see what's there. So I actually don't know what we'll find. We'll see. All right. So it's not really a scenario-based, like whodunit kind of thing. Like we're not going to try and solve a case or anything like that. But you should look at the exercises that we do today and try and think about like how would you use that in a real case, that type of information that you're seeing, right? That's kind of the gist of it, because we're really focusing on the tool. Okay, so Velociraptor. So what is it? So we're going to focus on the Windows system, but we support Linux, Mac OS, but Windows is the most supported and the most capabilities that we have. We're going to cover some of the basic topics, and there's just too much content to learn everything about Velociraptor, so you're not going to learn everything. It's only 4 hours, so we're just going to give you like a quick taste, and then you can explore later. So this is just in case you want to install a VM. All right, so what is it? So it's an open source DFIR tool. So it's open source. You can go out and download it from GitHub yourself and install it, run it on your own system without any problem, any licensing or anything like that. It's an open source, but most importantly, with the open source, there's a community of people behind it. People who are doing this day in, day out. And even if you're not doing this every day, then you can learn a lot from others and ask questions and so on. The interesting thing that we'll cover is that Velociraptor is using this Velociraptor query language, which we'll talk about a little bit, but we're not going to go into it in too much detail, but it allows you to write essentially scripts to collect different types of things from the endpoint. So you can write custom artifacts. We're going to talk about that. And you can hunt over thousands of endpoints in minutes. So we're going to quickly show you how to do that. So this is kind of like an overview of what it looks like. Normally we deploy Velociraptor in the cloud, on a cloud server or a VM or something like that. And then we deploy the assets. We push MSI packages to Windows machines, and RPM for Linux and things like that. And then once the assets are installed, they talk to the server, and we have this CNC command and control communication channel. And then our admins are able to task individual endpoints to collect, different types of information. But the cool thing about it is that it's persistent. So, and you'll see that with many other, like if you've used, other kind of endpoint tools, they use polling. A lot of them use polling, and so, it's never instantaneous, and so it can be kind of frustrating to try and, contact the endpoint, and so because it's persistent, it's very quick. So we're going to see that. All right, and normally we support all of these operating systems. I said that, and it's pretty fast, scalable, all this kind of thing. How scalable? We normally recommend 10 to 15,000 endpoints on the server, on a single server, but we've had people running 25, 30, people can push it by scaling up vertically. And then you can actually go a lot further if you're using load balancing and TLS offloading. That's the sort of, it's not a particularly high resource usage, so you'll see it's pretty efficient. And then we have this multi-server deployment, which you can read about. We won't talk too much about it now. All right, so what we're going to do is we're just going to get our hands dirty and jump straight in. So we're going to install it and just have a look at the UI. Now, Velociraptor, it's supposed to be installed in the cloud, as I mentioned, but it has this GUI mode, right, where we just bring up the GUI and we are setting up like a demo system, basically, with actual clients, but all running on the same machine, right? And you don't have to do anything to configure it. You just run it and it just works, right? So it's very easy to do. So first of all, we're going to do that now. So we can download the binary from GitHub. So just click on that. GitHub Velociraptor. Yep. Just search for that, and you'll find our GitHub page. And just go down to the little releases tab here. Yep. And click on the 7.2 release, which is the latest one. And for this one, we're going to be using the .3, which is the latest release. So you got to scroll down to the 7.2.3, and this one's a Windows machine. So we're going to use the AMD 64, the Windows AMD 64, and then download it, right? So off it goes into here, and depending how fast your network is, it downloads. So this is the actual executable, and it doesn't really have any other dependencies or anything like that. It's just the executable. It just runs by itself, and it contains all you need to deploy and run it. Now, it's the client, the server, they're all the same executable. There's no differences. It's super easy to deploy, and I think that some of the people say, if it seems like you, if it seems too easy, that you're doing it right, because it is pretty easy to deploy. So let me just start up command shell and make sure that you should be administrator here. I mean, so that we can access some of the forensic artifacts that we need to later on. It will work without being an administrator, but then you won't be able to, read like the raw hard disk and things like that. So if it's an administrator, that's better. So let's go to the downloads directory, and there's a little other file here, but this is the file that we've got, right? Velociraptor, and we could just run that. Now, if you just run it without, any arguments, it just prints like the help, right? But for this exercise, we're just going to run with the GUI. So you just go velociraptor.exe GUI, and off you go. And what that will do is it actually sets up a configuration by itself. Okay, well, it brings up Edge by default and just opens up a browser. So it's going to do like a self-signed server with self-signed certificates for testing. And you can see that it's listening on the local host only. so it's not open to the world, obviously, and it's just allowing us to emulate a full Velociraptor network. So you just click through the privacy warning, and there we go. So it just comes up. So this is actually a fully functional Velociraptor deployment on Windows. We don't normally recommend people do it on Windows, but just because it might not scale as well. But for like little deployments, I mean, we've had people using Windows for like 5,000 endpoints or something small like that. It's fine. But for very large loads, probably not. Okay, so this is it, right? So we've done it. Actually, let me just close Edge because I want to open it in Chrome, but that's okay. So what it does is it starts up the localhost on port 8889, which is the UI. So we have the UI, and then the password. It just has like a hard-coded password, admin password. But this is only just for the demo site, right? And when you're doing the proper deployment, you set passwords and all these sort of things, right? But this is just for the demo type deployment. So once you guys have that set up, then we can start to play with it, right? So basically, it's just it's just like a quick setup. So let me just close some of these. Okay, and then once we start it up, then you can also, so what it does is it uses, so Velociraptor doesn't have any requirements like a database and, and load balancer and blah, 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 right? Because it's really designed to be very lightweight, very cheap to run, very easy to deploy, right? So we don't really want to have a lot of, you got to set up Apache and you've got to set up Java and you've got to set up all the, no, we don't have that. This is it, right? This is the executable it runs. So basically it uses files, just files to write on. So we don't need a database. We don't have any need for that. Like we don't use Elastic or anything like that. So what we have is just a directory. You say, this is the directory where you can store your files. That's it, right? So by default, when we ran it before, then it uses like the temp directory for just somewhere temporary. But if you want it to be more permanent, you can give it that data store flag and just say, just use this data store, and it will persist, because otherwise it goes into the temp directory and it can get cleaned out, right? So, and then you can see it just sets it all up, creates a config, and starts it up. So it's just like a pre-canned, deployment. That's it. So now we can start to have a look at the UI and see what we can do. So let's do that UI tool. So this is the welcome screen, and from here it tells you there's links to some common tasks. But if you go onto the left side, then you can see the sidebar, and these are all the different areas which we're going to explore as we go through. But the main one is like the home one, which is the dashboard, and that is just like a dashboard, right? It just tells you a little bit about the server. But the most important thing here, I think, in my opinion, is these graphs that show you the amount of memory and CPU that your server is using. So that's important to know. And over here, the number of clients that you have connected to the server right now. And when we run the GUI command, it creates a client and a server. So otherwise, it's be pretty boring, right? If you just have a server. So we have a client and a server, but they're both running just on different threads in the same process. So we've got someone to talk to, right? Otherwise it'd be boring. So we have one client, that we can talk to. But normally in a deployment, you will see this graph going like, really high, and as your clients come online, and they'll just, go up and down. The weekend they go down and up, during the week, 9 to 5, that kind of thing. So you'll see these kind of patterns. This is for multi-tenancy, so we can do multi-tenancy. But we won't talk about that today. And then we can see, how much disk space we've got, and and the version down here. And these are the users. So we've got, RBAC, role-based access control with users and all this kind of stuff. But you'll see that we create, for this GUI command, we create just an admin user with a set password, right? That's what we use. But so that's just an initial thing. So okay, so that is the dashboard of like telling us about the server. So how do we start? Well, I said we have one client connected, so let's search for it, right? So if we go over here, this is our client search bar that allows us to search for clients. So normally when you're doing incident response, you're like, oh, there's this machine, and you'd want to search for it. So that's almost always where you start searching for endpoints. And here is like the pre-canned search. If you just click show all, it will show all the clients, but you only have one. So here's where we can search for it. This green thing, it just kind of filters clients that are online versus offline, right? So if they're currently connected, they're online. And then we just click on that to go to that selected client. Before we do that, I just wanted to show you quickly that we can use labels to group clients together. So, like say this particular client was something that is kind of suspicious, like, maybe we think it's owned, right? So we can actually go over here and add a label and say, okay, owned, right? And then it will attach that label to the client over here, see? And so now we can start to target it. So we use labels to kind of control how we target it with hunts and reporting and these kind of things. And really the investigation, you drive the whole investigation with labels, because you kind of like look at all the machines and then go, oh, I think this one's owned, label that, straight away it goes into the label groups, then we're doing more detailed analysis of that and so on. So labels are really cool. Okay, so when we click on that client, then we can see this, and so you can see over here, we go into the host information sidebar. Whoops. And this is just giving us like overall information about this, host. For example, like the version of the clients, which is 7.3 because 7.2.3, which just installed it when it was built, these kind of things. And then the IP address, and as I said, in this case, there are local hosts because they're connected, locally, so it's not that interesting, but what kind of machine it is. So we've got some information here. But the next tab along, so that's the overview, right? The next tab along is the drill down. And this is where we are just getting a little bit more information about this endpoint, but the most important thing here is the telemetry. So we are really careful about making sure that the endpoint is behaving itself. It's not using too many resources, not too much memory. Like that is something a lot of people worry about. If you're deploying an agent, they need to know that it's not going to kill the endpoint kind of thing. So we always collect, by default, you can turn it off, but by default we collect a sample of footprint on the endpoint every 10 seconds so that we could see what was our impact on the endpoint, like historically, and we can look back to say, what we were doing. So we've got that, and various other information like the active users on the machine and that kind of thing. And then we can go along again, and this one is like a remote shell, right? But we prefer not to use it because so the problem with the remote shell is that, like, if you mistype like rm-rf, you can take out the endpoint, right? And because it is like really free for all, so you can't really use that unless you're the user administrator in Velociraptor. It's like a pretty privileged thing, but it's still kind of useful sometimes, and that's where a lot of the EDR tools mostly have that, right? So they're like, yeah, the only way you can reach out to the endpoint is to run some shell script or shell command or whatever, but it's kind of risky because it's unstructured, and like I could do dir slash and then or c slash something like that, and it will run with PowerShell. I can run some PowerShell thing, and and it will do that, right? So that's good, but we have better ways to do that than to run free-form. So we prefer not to run free-form PowerShell scripts, but it's good to have the ability to just run PowerShell scripts if you need to, but we prefer not to. So it's good to be there, to have it there. And I know that a lot of people, when they first start off with Velociraptor, they use this really heavily because they come from that world where that's the only tool you have. So, that's kind of their, that's where they're coming from. All right, so let me just go through the slides and just see if I did mention something. So yeah, the dashboard, our user preferences, that's a really important part, believe it or not. If you click on your user tile up here, then you can change your user preferences, user settings, and we can change our password and things like that. But this is kind of cool. You can change the theme. So that's a dark theme. Just go over to the. Sorry. Yeah, so we can see that. So we've got like, this is a dark theme. Sorry. We've got this is the classic one from ages ago. There's a pink one that a lot of people love, and this is the new one, which is so there's this N-curses one, which is supposed to look like, which does. It looks like an old text-based N-curses thing. Looks pretty cool. And then this one's a really new one, just a dark version of that. So this was actually submitted to the repo like this week. So if you guys love it, hate it, feedback, right? Just file an issue on GitHub, say I hate this thing, I love this thing, whatever, right? So this is the beauty of open source. I actually quite like it. The purple is cool, and the colors are nice, but the font, yeah, it's hard to read, I think, but yeah, I don't know. Some people love it, so that's why it's there. But I'm going to just go with the standard, so the default is going to be this, the Velociraptor Lite, because that's just the default. So we picked it as the most generic, neutral one. All right, so we talked about that. Oh, the other cool thing about this user preferences thing, and this is important. So you see how like timestamps here, these are the timestamps, and they're always shown as UTC time. So the Z, like at the end, is a Zulu time. But it's really hard to, so that's the most accurate, like forensic, like legitimate, time zones. But it's really hard to work with. So over here in the UI, we can change the time zones. So like if we want to do like Brisbane, yeah. So let's change it to like a Brisbane time zone, and then it will. So the times are always shown in RFC format, which means that you have the time plus the time zone. So the times are always accurate in whatever time zone you have. They're always unambiguous and accurate and correct. But the choice of which time zone to use. And that really helps because when you're looking at times in the interface, then you've got the +10. It's still the same time zone. It's still correct, but it's easier to look at it. So that's a little bit of a UI feature that's really helpful. But also, if you hover over the time, and a lot of them will just tell you like when it was created and things like that. I will say like 2 weeks ago or 1 week ago, whatever. So and then also you can change the language like. German, whatever. And anyway, this is getting a bit fancy. All right, cool. So that's the user preferences we talked about. But okay, so that was fun. But now we're investigating a client. So we search for it first of all, and then we find it. We can search for it by a number of different things: by the host name, MAC addresses, IP addresses, and the labels that I mentioned before. Like so. Remember how we had the owned label? So I can actually do like label and then owned, right? So it's showing me all the labels and it will show me all the owned machines, search for it. So that's why we use labels, because it helps us quickly pick out the group. So, all right. And then we went to the client overview, which we could see like the, information about it. We saw the shell commands, and this one is kind of, so this is an example we could do that again. Oh, but it shows you in the screenshot. Like when it's handy to do that. Like this is a PowerShell command to find a local group admin. So when they have a local administrator on the endpoint, and so we can run that and just see all the local administrators on the endpoint. Because PowerShell is like the universal scripting language for Windows. So it has hooks into pretty much anything. Like any program will have a PowerShell module, right? So if you have something like Office 365 or Exchange or whatever, it will have a PowerShell module. So Velociraptor is never going to have built-in support for these things. So it's always really important to be able to call PowerShell for those things, that require, All right, so let's say that I have an alert, this machine is suspicious. I want to look around and see what's going on with it, right? Like what's happening to this machine. So one of the first things that people want to do is they want to just kind of reach out across the network and just have a look. Because a lot of the time there'll be like a virus detection or something like that. It will say, hey, there's a dodgy file. Let's have a look. So this is what we call the VFS, or a virtual file system. So let's have a look at that. So here's my client, right? And if I click on this VFS button, or also I can go to the same place, here, but it just depends where you like. It's both the same. And then I have this tree view kind of thing. So over here there's a tree view, and then we'll see over here there's going to be something soon. So over here we have, these are called, the top level of the tree is how we access the files, right? So the auto accessor, it's called in Velociraptor terminology, the accessor is how we access the files, right? So the auto is just automatic, which means that we're going to use the APIs basically to access it. So we're going to do that, and then the first thing we do is refresh this directory. So what is this view? So this is a view of the files on this endpoint, right? But we don't know what files are on the endpoint because we're talking to the server, right? So the server keeps a record of a cache of hey, I know this directory, that's the content because last week I listed that directory, and I knew. So it's like a cache, right? So it's going to be out of date because they're not really querying the endpoint. You're just looking at what we know about it, kind of thing, right? So when we click this button, that syncs with the endpoint. Because remember, the endpoint can be offline, right? It can be just not there. But we still have that cache, so we can look through, right? So, and so this is what we're doing. So we're syncing one directory in, right? So you see, so here's the C directory, C drive. And then we go again, and then we'll get, the next level in, whatever. And then, at some point, so there'll be maybe users, right? And then I can just do a recursive refresh this directory recursively, right? So if I do that, then it's going to go and list all the directories and then just kind of sync up with the server. So then that makes it a little bit easier then, to navigate. But you probably don't want to do it on the C drive because there's too many files, but I mean, you can. It just takes a couple of minutes, so, and then we can just go in and have a look. So, so this is really cool because, so it's good to do this very large sync from the top, because then you can just kind of look around the files, and a lot of the time there'll be a virus detection or something they ran Mimikatz out of the temp directory or something like that. And so you want to be able to look, in the temp directory, so you are, okay, this is the administrator, we got app data, local, and then temp, right? And then, there's all kinds of things. And so now we are reviewing, let's say, the temp directory, right? So down here, we have the status of each file. So we can look through here, and, and we can page that. And also we can search, filter any of these, right? So if the name, so we can, filter the name or whatever. But let's say that, we get to this particular file. I don't even know what these files are because it's the temp directory, right? So let's say there's this file, and I'm I want to see this file, right? So I can click this collect from the client, and what that will do is it will initiate so before we just saw metadata about the file, the file size, the name, and things like that. But we can just go and get that file out of the endpoint. So now we got it, right? So we have a little floppy disk. That means that we fetched it. So that's interactively we are fetching files because we are inspecting them. And so it's coming up here. Oh, it's an executable because it's got an MZ header. So that's the preview of the first, few bytes of the file. So I'm like, hey, I want to look at this. This is interesting. I don't even know what this file is, but so I click on the preview, and then I've got the full hex editor here, right? So let's have a look. So this is like a hex editor view, and I can just page through it and all this sort of stuff, and search for it. Microsoft, maybe it will have a Microsoft. Most files have Microsoft. Yeah, so it'll just sort of search through. I can do like a regex to search through this hex. Sometimes that's kind of all you need, because you're like, there was an alert. I'm just going to go look at this, find the file, take a look, and now in 3 seconds, I can say it's false positive, or I can say, hey, I need to look into that more details. There's something going on here. So this is like, it's a better interface than say Explorer or something like that, but it's a very basic use of Velociraptor, right? Like it's just like, let's go and have a look at these files. So far, that's like levels 1, let's say level 1 of expertise, which is useful, but not, super useful. And this is like a text view of the same thing. So it's like strings, running strings on the binary. So we're able to fetch these files. So that's great, right? So, and then you can also do things like, so if you're looking at this one, then you want to get this guy out of the way. So you can, click on this, and it will hide the bottom pane, and then you can increase, this, and it looks it's a bit easier to use, like to filter here, and and here we can like filter on exe maybe, I don't know. There's one exe, Python exe, right? So you can filter the usual things that you can do, with a table, right? So, and then over here we can export. We talk about that later. Okay, so yeah, so we talked about that. We talked about refreshing the directory, fetching the files, filtering the columns, right? And then looking through there. Now over here with the accesses is how we access it. So the auto, as I said, it just uses the APIs to access the file. But sometimes you can't really use the APIs to access certain types of files. For example, like the MFT or alternate data streams or something that's like very NTFS specific. So we can use the NTFS accessor to access like NTFS specific, information. Like, so it gives us more access to more. So it does like a raw parse of the file system. So I'll just show you, for example, like in the C drive. So this notation, //C drive, it's a device notation. And what it's saying is I'm opening that device in raw mode, and I'm looking at the bytes essentially and parsing them, right? So it's rebuilding the file system, from the raw mode, and it's getting us all of these, the MFT in particular is the master file table. It's not visible through the APIs, right? So we are able to get a lot of that low-level NTFS information. If we have time, we'll go through the last part is NTFS, so we'll see that more detail later. Yeah, so we refresh, we did that. And the VFS interface, we talked about the preview. We could see a file, preview it, and we talked about the UI, showing the UI there. Sorry. And we talked about the hex strings, the regex searching. You can also do hex searching and so on. So it's quite a useful interface to just quickly look at files and see what's going on. Okay, so any questions so far? Are you guys following this? Is that like useful to you guys? Do you think it's cool? Yeah.
I've got a quick question.
Sure.
If you know you want to get further down into the tree, not go there directly instead of recursively having to go through.
That's an excellent question. It's a very brilliant question because it leads me to the next part. And you've hit the nail on the head. Because that interface that I showed you is a pain. Let's face it. But that is a useful interface. Like, when you're in Explorer, the same thing, right? You're clicking down and, in Explorer or Reg, or regedit, the same thing. Like, oh, I need this registry key, and it's like 500 levels down, and I have to sit there and click every single level, right? So it's not an ergonomic workflow, and you're absolutely right. It's a pain. So this leads me to the next the next level. So we talked about like level 1, right? Now we're going to level 2, and that is about automation, making things efficient quickly, and the last word here is surgical. So that's exactly what you're alluding to, sir. When you're looking at, I want to get down to a place where I actually know where this is, and I want to surgically get in there and just quickly get that thing without looking at all the other stuff. And so this is a very good question. And that's why we have a query language. So for these cases where we already know what we're looking for and we are very specific about it, then we want to be able to write something in a query language to say, hey, just go and get this thing, parse it, split it up, get this information out of it, whatever, right? So we actually can go through and do that with VQL. And this is the main use case. So for example, like you might read a blog post or Twitter or whatever about a new kind of threat, new kind of vulnerability like Log4j or whatever, and then you might ask, hey, in my environment, do I have this issue? Do I have this vulnerability, or do I have this issue? And so you might be able to think up a unique way to find out. Like maybe there's a registry key, or maybe there's a file that you're looking for, or maybe a particular executable might have a signature, or whatever it is, right? And so once you come up with this idea of how to search for it, then you can write a VQL artifact, and then obviously test it and make sure it's okay, and then just hunt across your entire environment. I've got 50,000 endpoints. Boom, everybody just look at this registry key, tell me which one has it. And then you immediately isolate the ones that are vulnerable, and then you label them and investigate more or whatever, right? So then you basically start the remediation from there. So that's the idea. The loop is important. Before that, before we had VQL, then our endpoint agent was like, hey, we can do this, but you have to, like say, we're looking for files that are over, or registry keys that are over 20 kilobytes in size, because that's sometimes, malware stores binaries in the registry. And so we might say, hey, we're looking for a binary registry key that is, over this size. So if someone has thought of that when, they developed the agent, can we look for that? Then they would write it in some language, C++ or C#, whatever, and then build it, ship it, release it, and deploy it. So when the time from when the alert came and you actually had the capability could be 2 years, literally, because you would submit a ticket against your endpoint agent and say, hey, there is this vulnerability. Sometimes we notice that threat actors store, binary blobs in the registry. Can you please add that feature? They'll go, okay, that goes into a ticket system, Jira, whatever, and then it gets implemented. 3 quarters later, it's in production. Oh, it's a new release, and now we have to deploy it, right? So, as you all know, deploying is not easy. It takes us change management, it takes weeks. So that's the point, right? So what we're trying to do is shrink the time between, IOC and detection. All right, so that's kind of what the VQL looks like. It's basically like SQL-ish, right? But it's so it's actually fairly straightforward to learn. But again, I'm biased, so I don't know. But people do tend to pick it up pretty quickly because it's very similar to SQL, and it's pretty basic. So it's kind of like a cross between SQL and Python. If you guys are familiar with either of those, you'll be fine. So in the end, Velociraptor is like a VQL engine. We just evaluate these queries. And so the idea is, how do we take those queries to the endpoint? How do we manage them? We don't want people to type long queries in the UI, right? Because this is the same problem that we had with the PowerShell that we talked about before. If you make a mistake, it doesn't work, and like, let's face it, at 2 a.m., when everything is on fire, you don't want to be doing that. So we package the VQL queries in something called artifacts, right? Which is just a name. I don't know if it's the best name, but it's just a name. It's a YAML file that just kind of packages a particular query and gives it a name so that we can just name it, right? So it's a pretty straightforward concept, but it's human description and you can understand that. And then the VQL is kind of like packaged inside of that. So let me just quickly show you what is an artifact. So if we look here at the view artifacts part, so this is the way that Velociraptor manages these artifacts. It's like a library of queries, right, basically. And over here we have a whole bunch of artifacts. They have names, right? So you can pick up like, okay, memory acquisition. How do I do memory acquisition? Okay, let's have a look. So here we have the query, how to do it, yeah? And then we have the name and so on. If you click on that little pen, that allows you to edit the artifact, so you can change it. So you can take the ones, this is the one that comes with it, right? But we can edit it, and we can slightly customize it. And that's 90% of the time, that's what people do, is they take the artifact, they just change a few things, and then it suits their environment better. But basically, that's kind of the structure. We give it a name, we have a description, and we have some queries here. So you can change it. So you don't necessarily need to know about VQL, as long as you can, kind of say, maybe I want to add a where clause here or whatever, like just to filter some things, so you can 90% of the time get away with that. And then we call those artifacts. Okay, so you can have all kinds of artifacts. Like you can have very simple artifacts, and you can have extremely complicated artifacts with a lot of functionality. Like any programming language, right? You can have simple language or complicated language, right? So there is this balance there. But the important thing to remember is that the endpoint, it just knows about artifacts. It doesn't know about anything else, right? So everything is done with VQL. Everything is done with artifacts. So before, so here's my endpoint, and you remember how I went to the VFS and I clicked around and I ran some stuff. And through the UI, so the endpoint itself just knows artifacts. It doesn't understand anything else. So what it means is that the UI created a bunch of artifacts by itself, or collected a bunch of artifacts by itself. And so if we look here at the collected artifacts tab, then we can see all the artifacts that were collected on that endpoint, right? And you can see that every time I clicked in the UI, or certain functionality in the UI is implemented by just collecting different artifacts from the endpoint, right? So it's just done automatically, like under the hood. But in the end, they're just artifacts like every other thing, right? So when I ran my PowerShell, it collected this Windows System PowerShell artifact. And when I ran my list directory, collected this System VFS list directory artifact. So it just collects artifacts, right? When I downloaded a file from the interface, it just collects the artifacts. When is the break? Do you guys know? We could maybe have a look here, actually. That's why it's here. 1:30. Does it say the break? Doesn't say. Okay. Well, we've only been going for an hour, so less than an hour. So maybe an hour. Yeah, maybe we'll go like 2:30, I think. Yeah. Okay, cool. Okay. So these are just artifacts. So there are just certain artifacts that the UI uses, right? But we've got, as you've seen before, there's hundreds of artifacts in this interface. There's so many of them, and you can get more. So that's just the tip of the iceberg, right? So we can really get lots of artifacts out of this. And this is the rest of this workshop is about looking at some of these artifacts that are super powerful and allow us to do really, really cool stuff. They're just artifacts like everything else, just different queries. All right, so we talked about that. So as I mentioned, it collected artifacts, different artifacts. When I collected the download file, now you see here, the artifacts are, sorry. there's two kinds of results that artifacts can give us. The first one is rows, and we'll see what they are in a minute. But essentially, because VQL is a query language like SQL, right? So all you can get back is a table with data, right? Like, so it is just a query language, right? So they have rows, right? And or in addition to that, I guess they can transfer bulk data. So like, I want to fetch this file, so this is the bulk data. So it doesn't go into it's not a row, right? So these are the two different types of information that can be collected from the endpoint, either raw data or structured data. So that's basically it, right? Structured data or raw data, right? So they're the two different things, and so we can see how much data we're transferring. So for instance, here we listed the directory, and remember what we did in here is we did a recursive directory of C users. So there's going to be a fair few files in there, right? So each file that came back, if we look at the results tab, each file is, it's a table, right? So it has like, the name, the size, the mode, these kind of things. And we have 25,000, rows in that table that were, transferred, or actually 22,000 rows, and there's actually another source in here. So there's 22,000 files that that were synced, and some other stuff. So this is the total number of rows transferred. Okay, so that's what kind of artifacts do. But the whole point of this thing is to say, hey, someone did the research, someone figured out how to do this, or how to get this particular piece of information. So they're like the expert, right? So what we're going to do is we're using that. And so I don't have to be an expert. I'm just going to use that artifact and get that data, right? So, for example, when someone says, let's see where this browser went to, right? Like, a lot of the time we need to look at browser history. We'll have to figure out, did they download the malware from some watering hole or whatever, like something like that, right? And so we might say, well, where did the user go? So there is a science behind it, right? So we have, if they're using Chrome, then we need to know that there is a file, somewhere in the Chrome cache that has, SQLite, and it has all the right things, and there's a table in there, and then we query that, and then there's URLs and timestamps and whatever, right? So that's the expert knowledge of how to get to this data, right? But the idea is that in Velociraptor, I don't need to know that. As long as someone figured it out, there's going to be an artifact in there that says, hey, just give me the history. I'm like, hey, I just want to know the history, run the artifact, get the data. I just don't care, right? Like, I don't care about the how, I just care about the what. It's not exactly as perfect as this, because there are nuances. In some forensic techniques, there's nuances, like it works sometimes, it doesn't work in other times, and you kind of need to know that. But as a first approximation, it's a really good thing of basically it's just having your junior analysts having this powerful tool that just leverages that expert knowledge. So we talked about that. We talked about the anatomy of artifacts. So it has a name and the type and clients. And the parameters. So artifacts take parameters. We're going to see that in a minute. And now I'm going to show you how to collect a new artifact. So here we saw these are the built-in ones from the UI. But let's now try and collect a new artifact, something different, right? And it's not built in the UI. So one of the first thing that we're going to try and do is collect the scheduled tasks. And as you guys know, a lot of the time when malware is installed on the machine, they want to have persistence. So they want to be able to, if they get cleaned out, they want to get reinfected, right? So the way they do that commonly is to install a scheduled task. And it would say something like, on Monday, run this PowerShell script at 8 o'clock, right? And so let's say that on Friday, they get caught and they get uninstalled, right? Then come Monday, they get reinfected. They're back in, right? So that's the logic. So you might want to collect all the scheduled tasks and see which ones are suspicious, right? Because it's a very common persistence method. So let's do that. So we create a new collection. We're going to search for tasks. And of course, remember, it has hundreds of artifacts in here. So we're going to find the right one. Windows System Task Scheduler. We can read a bit about it. Yep, it's a common mechanism that malware users use for persistence. Great, okay? And so how does it work? So we can look at the VQL if we want to, but you don't have to. And then we go to the next level, the next step in the wizard, configure parameters. You can see that this artifact has parameters. Parameters are just a way that we can tweak the query somehow. So it's just like a program, right? You give it some arguments, some parameters, it changes some things, but the query we can tweak the query, control it somehow. And again, the artifact writer, whoever wrote this artifact, usually what we try and do is allow the user to tweak the right things, right? So basically, like in this case, it allows us to change where it's going to look for the task files, which are these XML files that contain information, and that's useful for when you just have a bunch of files and you're not on the actual endpoint. But normally the idea is that we don't really want too much configuration. We want to do 90% of the time the right thing, So the defaults are usually pretty good. You don't normally need to change them very much. In this case, we might want to also upload because we might want to also preserve the evidence, so we grab a copy of the actual raw data. Because remember what's happening here is that this query is running on the endpoint. It's going to look at those XML files. It's going to pull out the relevant information out of it so that we can see which ones are suspicious, and then grab them. We can also try and upload the commands. Sometimes they're running like another program, so like a malware. So we want to grab that as well. So we can try that as well. I don't know, why not? And then the next thing we configure is the resources. Usually, it's very hard to read, but there are some faint defaults here. So usually, when we collect an artifact, it runs at full speed, right? It just runs. But sometimes some of the artifacts are really big, like we've got to scan for keywords across the drive or whatever, right? So that takes a long time, lots of CPU cycles. We don't want to kill the machine, right? We don't want to interrupt the user. And so in that case, you might want to actually limit the CPU. So that's one of the options here. Or limit the IOPS, like how much. That's more important for cloud machines because IOPS are actually expensive because there's different limits on different cloud machines. Or sometimes you just don't know. Like, you might say, just grab all the files in the user's, downloads directory. I just want to look at them. And then it turns out the user was like an avid user of Pirate Bay or something, and they've got like millions of ISOs, and it's going to take you all day to download like massive amounts of data. So we always have a timeout, and also a maximum number of bytes uploaded. It's just like a rail, safety rail, to make sure that we don't overrun the system, because it's very hard in practice. The theory is not the same as practice, right? In practice, it's very hard to predict what will be the impact on the endpoint because you don't know what's there, right? So this is where the guardrails come in. If you are expecting to download 1 gig and you're getting 100 gigs, something's wrong. I want to stop. I want you to look at that again to understand why it's not doing what you think. So anyway, but most of the time, we're just not going to bother with that. So the defaults are pretty good. So we're just going to run that. Okay, so, and then as you see, remember how I told you before, it was a persistent command control. So I don't have to wait for it to poll or anything. It just does it, right? So it's immediately done it. And you can see, let me just show you the overview. So it took 5 seconds to do various things. It's transferred 158 rows and looks like 9 megabytes and a bit, and uploaded 197 files, right? So these are like the overall stats of what it did. Okay, so let's look at these tabs, and see what they show us, left to right. So this is the overview. It's just saying, okay, this is what ran. The next one along is the files that were uploaded. So remember I told it grab those XML files and also grab the commands that are referred to from there. So these are all the files that it got. So it got these. This is the one of the task files, and then we've got a preview here. So the same. You've seen the preview from before, right? But this one is, as you can see, it's a UTF-16, so it has a lot of dots, a lot of nulls. So if we do the text view, it's a little bit easier to read. And so you can inspect it in this UI if you want. And you can look at each file individually, but normally people just export the whole lot. This is just telling us what requests went out to the client, so it's like for auditing and things. And then this is the rows that came back, the results. So like a query, it returns back results, right? And in this case, you can see that, so this task, right? I'm just picking the first one off. There is a task in the task scheduler. It runs this command, right? And then we're basically trying to figure out where this command is. With this is the arguments. And then we're doing an authenticode check of that command. Is this a legitimate binary that it's trying to run? So is it signed? Who signed it? That kind of thing. Because a lot of these, this is a built-in edge update, right? So it's probably legitimate, and that's why it's signed, right? And then it's trusted by Microsoft. The signature checks out, so it's all good, right? So we can immediately eliminate that. So this is useful for post-processing. We're going to talk about that later. But basically, you can see that what we're doing here is we're trying to enrich the information with more information that helps us to try and figure out whether this is something to worry about or not. Because what we want to do is we want to reduce that, round trip of the analyst. Like, go get this piece of data, come back, think about it. Go get some other piece of data, come back, think about it. We don't want that. What we want to do is we want to say, what data are you going to need to figure it out? So you have everything at your fingertips. Go and get that data, come back. How would you make that decision? Trying to automate all that stuff, right? So as an analyst, I'm looking at these scheduled tasks and I'm going, who's running this binary? Is this a legit binary or not? No idea. So let's put the authenticode in there so I already know. I'm checking it on the fly, right? So in 5 seconds, I've cut down a process that would normally take a long time of manual back and forth, right? Yeah.
Is that authenticode a new inclusion?
I'm sorry?
Is the authenticode a new inclusion to the table?
To this artifact, it's possible, yeah. I mean, yeah, it's possible. The artifacts are updated all the time, but I think it is new in the latest version or one before. Yeah, artifacts change all the time, you see. I mean, people, that's the point, right? When you have a tool that a lot of people use, then you get this thing, right? Like, oh, I really want to know this extra bit of information. Let's just add that, and then you get. So this is how the community builds on one another, because sometimes the use cases are coming back from feedback, right? So it's really important. Yeah, exactly. So yeah, I think you're right. This authenticode is new. I don't remember seeing it before. Let's actually, you know what? Let's check, because it's in the screenshot. This screenshot is a bit older. So yeah, so we went through, we did the resources, we talked about that, then we collected the stuff, and then we talked about the files that are uploaded, and and the logs I didn't mention. So when a query runs, it also has logs. So they tell you about what happened on the query. So you can look at that to see if there's any problems or whatever. Like in this case, there is a scheduled task that refers to this file, but we can't find it. So it's possible that the task was just left over or whatever, but the file's gone. So it's telling us I can't find this file. So this is an example of like just logs that is useful to look at, oh yeah, now it's a different artifact. Okay, so yeah, not sure if we have a screenshot of this. We'll have to see. But yeah, okay. So the data came back in a table. So you can see that the results are basically in a table. So in this case, the scheduled task, it just returns one table, and everybody's happy. That's great. But sometimes some of the artifacts return multiple tables. So the example here is this generic client info, and that is an artifact that's run automatically by the system. You can see that there is an interrogation service launched it, and it just gets like information about the endpoint, like just what is it, what am I talking to, right? And so that particular artifact has a bunch of what we call sources, which are just different tables essentially of different types of data that it's getting. So here it's getting the list of users, as we can see down here, and then we've got some basic information about it. So it's mostly just information about platform and architecture and things like that. And then it has specific Windows information, which is the network info, computer info, that kind of thing. So, but this is an example of an artifact that returns multiple tables back, and we'll see lots of those later. So I'm not going to spend too much time here. Okay, so we talked about that. Oh, and then finally we can export that data. So let's say that we did this task scheduler, right? And we are like, oh, this is really important. I want to archive that, export it, whatever. So you can see that we looked at each file separately. There's 197. It's going to be super boring. So what we want to do is we want to create an archive, right? A download. So we're going to prepare the download. Click on that. And that's just going to take all that data that was collected and just put it in a zip file for us, and then we can grab it. So here it is, see, and I can just open that, and did I click on it? Click on that. Come on, yeah. Ooh, I clicked on it 3 times, and then and it's going to be in a zip file. And so in here, what we're trying to do is so it's actually, these days, it's actually legitimately an archive of that collection, as in you can take this to another machine, a different Velociraptor server, and import that. And so it's literally recreating that. So it has all the information that you need to know, that Velociraptor needs to know about rebuilding that from scratch. The queries, the logs, the requests, and then finally the uploads, which are the files and where they came from. And like these are obviously all the programs that were referenced from the like the Edge update. So we've got the executable itself here, right? So like maybe it's malware or whatever. So we might take that, put it in VirusTol or whatever, and then come on. And then also it has all the metadata. So we can import that into another request, another server if we need to. It's like an archive. Okay, so we talked about that. I'm just going to let you guys go for this lunch or whatever. Yeah. So the idea is that in VQL we put all the difficult things, right? All the like, how do you parse MFT? It's really hard. How do you parse the USN? It's really hard. How do you do really efficient, really fast globbing? How do you look at SQLite? All of these very difficult things, they become VQL functions and plugins, right? So then you basically expose this functionality, and then you take VQL, which is a very simple query language, and glue all these bits together to create new content, new kind of functionality and capability built on these very powerful like bits. Yeah, so query language. So we have an artifact exchange here, which is, click on that. Oh, this is the artifact exchange where people, can share artifacts. So we've seen a lot of built-in ones, and you can share that with the community. There's a screenshot, and then you can actually just import that into your server and use it. We could. Is it actually breakdown? Do you know? We don't know.
Lunch is already been.
Lunch, but there's a tea, right? Afternoon tea?
3 o'clock.
3 o'clock. Okay, so we don't have to stop. Okay, cool. All right, sorry, I was just trying to rush. All right, cool. All right, so this is how we get the artifact exchange. And you can see in the artifact exchange, if you click on the little, this is our documentation site. Lots of documentation and information, artifact exchange. Here, this is where people just share different kinds of artifacts, right? So various different things, right? So we can use that in our server. So let's say, how do we import that into the server? So there is an automated way to do it, and there's a less automated way to do it. So I'm just going to show you both of the ways. So the automated way to do it is to say, hey, Velociraptor server, go out to the artifact exchange, just bring me the lot, just bring the whole thing. Right? There's a few hundred artifacts in there, I just want to import them. And how we do that is we go to a server artifacts here, and we run some VQL on the server. And the VQL on the server is going to bring in that artifact. So this is a server artifact. If we search for import, there's actually a whole class of different artifacts that import from different places, not just the artifact exchange. It used to be just the artifact exchange, but there's like Rapid7 Labs, there's Registry Hunter, which we'll talk about later, and so on. So in this case, what we want to do is the artifact exchange. Yep. And so, you can look at the VQL if you want, but essentially it goes out to this URL on GitHub, which is a separate project that we're managing. The documentation side is in a different project, and we can just go ahead and launch that. And what it will do is it will go out, get this artifact pack, which is just a zip file with all the YAML files in it. Just all the artifacts are in a zip file, and import them into the server. And then, you see it's importing them all here, right? The name, description, etc. So now, when we go to the View Artifacts viewer, so we're going to see a whole bunch of, you see these ones, they have the user, so the user, little picture of the user man, that is for custom artifacts, for ones that are not built in. And then we have an exchange dot detection, so that the prefix is reminding us that's from the exchange. You don't have to have a prefix in there, but that's the default, so you can clear that if you want. But then this came from the exchange, artifact exchange, right? And so you see these hundreds of artifacts in here that came from the exchange. So the artifact exchange is less tested. So what we try to do is, because we have so many artifacts now in the project, we try to have very rigorous testing of the built-in artifacts. So they have to have tests, and they have to have high quality. And then the artifact exchange are more for the community, because we don't want to have, if someone is trying to send us an artifact and say, hey, this is a really cool artifact that I found useful, we don't want to say, oh, okay, now you write tests and put it in CI and do all that things, because it's going to discourage them. So it's less well tested. So kind of use at your own risk kind of thing. So some of them are probably broken, but maybe it's a starting point from something else. So anyway, take that with a grain of salt with the artifact exchange. A lot of them are very good, a lot of them are not great. But we're trying to maintain the standard of the built-in ones to be really good. So that's the exchange. So a lot of the time, people use Velociraptor on disconnected systems where, it's not on the internet, right? So it's like an internal network, or they don't have access to the internet. And so if they wanted to download the artifact exchange on one of those systems, then it's difficult, because the server can't just go out to reach out, because you see how I've done it here. Windows is like this. Okay, so you see when I ran this is the artifact. It goes out to this URL, right, and fetches that zip file, and then it uses that. So the server itself is going out there, but sometimes you can't do that, right? Because you have egress or whatever. So in that case, you can download the zip file, like I just did, like that zip file, the same one, the artifact exchange zip file, right? And then you can manually upload it in the UI. So you basically just go to the artifact collection here, and then this button here, upload an artifact pack, and I can grab the pack that I just downloaded from, like this one. Okay, and what it will do is and then I have to click upload to actually upload it to the server, and then I can see all of these artifacts, and I can just do them all, or I can just do one or two or whatever. So it's more fine-grained here, and it's more of a UI type thing. Like say I have like 400 artifacts, and I only want to know about, I don't know, Windows ones, so Windows ones. Yeah, so there's going to be a few less. And then, if I go into the end, there's still 256 artifacts, so it's quite a lot of Windows ones. So that's the manual way, and that's for disconnected systems. So, yeah, cool. So that's importing the artifacts. So we have all of these artifacts, we have all this power at our hands. What can we do with it? How do we do DFIR? We want to do DFIR, right? So now we're going into the more interesting part of the talk. So if you've been to Auscert last year, you would have seen us do this talk as well. And the first part is kind of the same, because it's like you've got to show like the tool, right? So it's the same. But then once we finish that, then we're going to talk about all the new stuff after that. So let's get through this really fast. So the file finder is like the next most useful thing, or the next, like artifact level 3. Now we are up to level 3, right? So that goes directly to your question about how to find a file that's deep inside of the file system without clicking your way through it. And essentially, we use the file finder for that. The file finder is just a particular type of artifact that does a thing called a glob. So let's have a look at that. We go up to the collected artifacts, and we will start a new collection. We're going to search for the file finder, and there's various flavors of it, but this is the Windows machine, so we'll use the Windows one. And you can see that it's basically like a Swiss Army knife of things you want to do when you search for files, right? So all kinds of stuff. And it's written in a way that's performant, so it doesn't need to do all the things that you don't need to do. But basically, it gives us all these controls of what we would want to do. So in this case, and you use these wildcards, stars, like it's just a glob, right? So stars to search for the file name. So we can search for file names, right, with these glob characters. We've got a table here, so we can put lots of them, if we wanted. And then we could also add a Yarrow rule in here, so we can search the content of the file, right? So we can say, like, find me all the executables that might, use this log DLL or whatever, like assigned by this or whatever. So you can come up with some Yarrow rules that you can use to match the files that you want. So keyword searches, that kind of thing. And then once we do that, we can upload the file, calculate the hash, and then we can also limit it by dates and times. And then we can also do some VSS. So VSS is volume shadow copy, right? So if a file was deleted, but we have a volume shadow copy taken. So in Windows, we can take a volume shadow copy, which is like a checkpoint, I guess, on the file system. And then we can recover files that were deleted, but are still in the checkpoint, right? So we can do this VSS analysis if needed. But anyway, this is the Swiss Army knife. So I think the exercise in the slides is a very simple exercise. Actually, we find, we need to do a lot. Find all the executables in the user's home directory, right? So, that's a common one. So we're going to write a search. So C users, and we're going to do recursive search. So we're going to go like deep into that. If we do a star, that's a recursive search, right? / star.exe. Now you can use the / or / doesn't really matter. either will work. And the other important thing to remember, this is a globe. It's not a regular expression. So those stars are like, so globes are very simple. They only have like stars and question marks. That's it, right? So they're not like a regular expression. They're very simple. And what we're going to do is we can either upload the file or grab the hash. We'll just grab the hash for now. And right, so we just do this, right? So so launch it, and that allows us to like reach in and search for what we want very quickly. And you can see that we've already got some results there. So okay, so it's done. There's 77 files, and we've got the hash. Okay, there's different hashes, right? And so okay, idle. So there's looks like there is idle.exe. Idle is like a Python program, and it looks like it was installed in the user's app data roaming. So it's somewhere like in a temp file or like that. So we've got all of these things, and so we said, oh, let's just hash these files. But like if I look at this file and I'm like, well, I don't know, is it a good file or a bad file? I don't know. So we go over to the hash over here, and we right click. Right click. Copy the hash, put it in VirusTotal. So we actually can do it, not this way. Yeah, but that will copy that to VirusTotal. But yeah, okay, whatever. It still goes there. It copies that whole thing. But anyway, so we copy the hash, right? And we'll go to VirusTotal. Yeah, so we're going to find. Well, maybe you have to take the quotes off. And look, it says, oh, okay, this is, what was it? Idle. Okay, great. So it's probably fine. It's, VirusTotal says it's green. So that kind of thing, right? So we'll have a look later on. But anyway, a hash is usually enough for being able to clear with VirusTotal whether it's okay. But that's a useful thing. We can see that there's some see in this case because we did the Velociraptor GUI, then the data store is in the in the temp files. So whatever we collect is actually what we're seeing. It's like looking in the mirror. All right. Okay. So that's the exercise, right? It's super easy. But actually, when you think about it, searching for files is like very common. It's probably 40% of DFIR work is like, I had a virus alert, of this file, this malware, maldoc, whatever. Let's find it, and you can do that across the entire thing. So now we have new content, so that's a bit different. And so this new content is mostly about features that were implemented since the last Auscert. So since the last time we did it. So it's about Velociraptor notebooks. So somehow the image is on the wrong place, but doesn't matter. So the notebooks. And notebooks are about post-processing, and we've almost always had, for a few years we've had notebooks, but they've become very, very powerful in the last few releases. So I actually want to talk about the notebooks now, most of the time. So what are the notebooks? Notebooks are an interactive way of doing post-processing and analysis. And it allows us to be collaborative. So a lot of people can work on the same notebook, and we can do reporting with that notebook. I'm not going to say that you can use the notebook to just, hit a button, bind it up, and, that's your report, right? That's not really the case. Obviously you're going to need to, report writing is a big part of, communication, but the notebooks are a way of trying to collate information that is and then post-process. So I'm going to show you how a workflow that we recommend to do like this analysis, collaborative analysis. Okay, so we're going to start off with the notebook, and we have this tab here, notebooks here. So here in the notebooks, we're going to create a new notebook. Okay, we're going to call it analysis. Okay, and this is where we're going to put all analysis stuff. Now, on the system, I can share it with all the users of the system or just certain users. But if I don't, then it's private, just me. But it's not private from a security perspective. It's private because it just doesn't show. It's a search thing, right? So, and then I have templates. So these are the different templates. We're going to talk about templates in a minute, but I can create a notebook with a number of different templates. I'm just going to use the default. That's the normal one. And then launch. And you can see that what it does is it creates a notebook here, and then down here I have this welcome to Velociraptor notebooks. So that is actually the notebook, right? And so what makes it a notebook is that I can edit the content. So a lot of people, and this is something that is probably not the most intuitive user interface, because they're looking at it and going, well, what do I do now? But actually you have to click on it. Okay, but once I showed you that, now you'll never forget, right? So that's why we don't really fix it, because what we want to do is we want to create like a document, so it just flows, right? So it just doesn't have any, like, we're not going to put any like circles or like squares or whatever, because we want it to just look like a document, right? So that's why this is like a bit harder to conceptualize. But once I showed you that you click on it, then it works, right? Then you'll never forget now. So that's the first thing. So this is called a notebook cell, right? So notebooks consist of cells, different cells, and each cell can be a different content, and we can edit the cell with this button. And so here let me just make the fonts a little bit bigger so we can see them in this view. Okay, and then here we have the type of the cell. So here it's Markdown or VQL. So there's two types. Markdown is just report writing type data, and then VQL is we can run VQL directly into the cell to evaluate the cell, the query in the cell. So we'll see that in a minute. But in this case, this default one is, welcome to Velociraptor, right? So it's Markdown. So, like that's a heading, and these are, bullet points, that kind of thing. And then we can create new cells here, either Markdown or VQL or other ones. And, we can recalculate, move them up and down, and, it's pretty self-explanatory. So we did that. That's the default. We created the notebook cell. So this is a notebook. So what can notebooks do? So first of all, I'm going to show you how to create a custom template of a notebook, right? So this presentation, as you've seen, it also comes as a notebook. So you can see it online right now, right? So it's not up on our website, but it also comes as a notebook here. So I'll just show you, this is an example of a template. And you can just let your imagination run away with that. Is it like, I can create my entire process around this notebook, right? Like, collect all of these things, whatever, right? So let me just right click, save link as. Yeah, and it's a YAML file, artifact.yaml. Okay, let's save it. And then I'll open it. So there it is, artifact.yaml. Open in Notepad, that's great. And it's actually quite a long one because it's a long presentation, but I'll just show you. Copy. And then I'll go over here. Now it's just an artifact. It's a different type of artifact. So before, how you've got these are all different artifacts, right? But now we're going to make a different type of artifact, which is called notebook artifact, which is just a template of the notebook. So it's still the same interface. We're doing the same thing. We're going to create a new artifact. And by default, when you add a new artifact, the UI just says, oh, here's a template. Go and edit it, right? So it just makes it like easy to start. But what we're going to do now is we're going to clear that, delete that, and we're going to paste the one from Notepad. So the one that we downloaded. So we're going to save it. Okay, and it's just a new type of artifact. You can see that there's different types here in the search interface. So you look at the notebook templates, and it's called notebooks.presentation, right? I mean, it's just a very generic name. You can change it, whatever. So now, when we create a new notebook, like we did before, right? And we're going to call it Auscert 2024, for example, right? And this time we're going to choose this template, the one that we just did, right? Notebook presentation. And it's going to be big, so it's going to take maybe a couple seconds to do it. So it's done it. And so that is the presentation, right? So most of this is just Markdown, right? Because it's mostly just slides and stuff. But you can add like VQL or whatever. But imagine that you could write your template to say, I want you to, this is how I do a playbook. Like, I get an alert, I look for this, I look for that, I look for the other, I report to this. I might have a template to say, if you need to contact that team, that's the contact number for whatever, like EDR or whatever. So you then have all of the instructions built into Notebook, and then the analyst just goes through the Notebook and just figures it out. So this is a new addition. It's actually a really cool way of organizing processes, and reporting. So I wanted to show you that, and okay, so we've done that at the network, the template. And we did that. Okay, so we have a number of different types of notebooks. We have like 2 minutes. I'll just quickly show you. So this is called global notebooks because they are up here at the global level, and so they are global notebooks. But we also have notebooks that are attached to a collection. So remember how before we had all these different collections, like the file finder, right? So this is where we looked before with the file finder. And you'll see a notebook tab here. And so that is a collection notebook. So it's basically another notebook that comes, for free with every collection, right? It's part of the collection. You don't have to do to create it. It's there, but and it's used for like post-processing that collection. Like if we wanted to, do more VQL queries, then it already comes with, preset queries, and, I can go in here and change things, and, like if I want to post-process the result further, like where, I don't know, what was it? OS path matches, what do we say, idle, like that. So that will further narrow down the results. You see there's only one hit out of 77. So we're going to use those in a minute. But that's called a collection notebook that we can use to narrow it down further. And so the idea is that we can copy cells from one collection to another. So let's say that we are working on a collection, and we like let's say that we are post-processing. Like let's say this one. Just an example, right? And we're happy with the result, and we're like, okay, this. So we narrow it down. We're like, this is important. I want to put that in my analysis notebook, so all of my collaborators can see that, right? So they can all see like we're working on this together, and this machine, because this is in the machine context. It's only this machine. It's collected from this endpoint. And I might have, narrowed it down and said, yeah, you've got a suspicious user over here. Like I might go, whatever, where, user, where name. You can see the completion, by the way, equals administrator. I don't know, like that. Okay, so like, oh yeah, that is a suspicious user, let's say. Okay, so that's relevant to the investigation. So what I do is I go up here to this button, copy cell. And I'm going to copy that cell to my analysis notebook. So I'm going to go and put that there, right? So now, when I do that, it copies that cell, wherever it is, over to my analysis notebook. So if I go over here to the analysis notebook, then I've got that. So you can see that a user has just copied that in, and it's now in a central location. All the other analysts can see that. So that is my results. And I can actually go and continue on narrowing it down, right? And you can see what it's done is it's basically put a reference here to the original collection. And then I can go in and, and make some notes. Because this user is super bad, whatever, right? And whoops, and then I've made my notes, whatever. So now it's like an interactive thing. Everybody's like doing it. So this is a workflow that we now started to develop of just kind of like using that as a central collaborative thing. Okay, cool. So that basically is we did that. Copying the notebooks. Okay, and that leads me to the next part, which will be after the break, which is the more exciting stuff about detection. So we're going to do that after the break. So sounds like there is something going on over there. So we'll break now for the morning tea. Thanks. Sorry if we went a little bit overboard.